Good morning, students. Today we discuss about grouting. Then what is grouting? Grouting, it is a ground improvement through the injection of fluids in soil or rock mass. Then what are the objectives of grouting? The objectives of grouting is to increase the shear strength of the soil, reduction in pore pressure, reduction in seepage, the control of settlements, underpinning works, sealing cracks in tunnels, repairing of cracked and damaged masonry concrete, etc. Then what is the principle behind this grouting? So usually grouting are having adhesive materials. These binds the soil particles together and increase the adhesion between the particle. So once the adhesion between the particle increases, automatically the bonding strength increases. The bonding strength, as bonding strength increases, degree of packing increases. If degree of packing increases, automatically the density and shear strength will be increased. Then next comes types of groutings. Types of groutings, there are two types. One is suspension grout, another one is solution grouts. So first one is suspension grout. Suspension grout has particulate grouting material which is suspended in medium like water. Means it is the material which is suspended in medium like water. Then second one is solution grout. Solution grout are the material which is dissolved in liquid like water. So in this suspension and solution grouts, there may be some chemicals and materials will come. They will be discussed here. First one, in suspension grout, first is grouting material. So grouting material may be used as clay or bentonite. The clay and bentonite are used to reduce the permeability. Then second, cement mixtures. Cement or cement mixtures. Cement mixture means you can use cement or it may be mixture means cement and sand fines. So these are suitable only in fissured rocks. Fissured rock means the rock which is consist of air cracks formations. Next, rapid hardening cements. So rapid hardening cements used for ground with high flowing water. Wherever there is a water pressure, then we can use rapid hardening cements. Then next will be high alumina cements. Usually high alumina cements are having higher strength and resist of attack of sulfates and dilute acids. Third one, that is grouting with asphalt emulsion. So grouting with asphalt emulsion can be used as a grout to fill the soil voids or rock fissures. Next is solution grout. That is solution grout consists of silicate derivatives, lignosulfate derivatives, then resins. Usually silicate derivatives are sodium silicate, are also called as water gas, which is commonly available and relatively and inexpensive aqueous solutions. So these silicate derivatives used in soil voids or rock cracks at the grout, as the grout. Next, that is lignosulfate derivatives. These lignosulfate derivatives made from lignin, a residual product from wood industry. These additives are added for control of time, gel time and uniformity. So usually this is having setting time, that is 10 minutes to 10 hours. And last one is called as phenoflast resins. Phenoflast resins comes under solution grout, that is last one. Usually formaldehyde combination is a resin result from phylomerase of resonil. This gives, that phenoflast resins gives the high strength and which is used for controlling the flow of water. This is regarding types of grouting. Next, factors affecting groutings. The main factors affecting groutings are, first one is grain size and its distribution. Second, permeability of the medium. Next, relative density. And last one is properties of grout. So these are the factors which affects the grouting. First we discuss about grain size distribution. So usually if the grain size is having bigger one, then the grout can be easily moved into the spaces and reach the destiny. If the grain size is smaller, then what happens? Grout is not easily moved into the spaces, pore spaces, then the grout will not having a proper solution. The next is called as, if you use for well graded soils, if the well graded soils are there, then what happens? Well graded soils, then they have smaller gaps. If smaller gaps is there, then grout will not easily move into the pore spaces. So this is not effective. Only that grain size means, if the grain sizes are very big, then grout is easily moved and reach the proper destination, means you can achieve densification as well as increase the shear strength. Next, permeability of the medium. So permeability also affect the grouting. If the permeability is bigger, means higher permeability, that is having, see here. So clean gravels having permeability rest 1 to 10, maybe sand it is 10 raised to -3, then maybe clay, that is up to 10 raised to -7, less than 10 raised to -7. So if you are having a permeability, higher permeabilities, then your property is very good, means the penetration of grout will be high or maybe medium. So grout can be easily moved into the grout spaces, then it reaches a proper destiny, and whatever objectives we decided, so it can be achieved if you have a higher permeability. If you have a lower permeability, like it may be a silt or a clay, then what happens? The grout will not easily move into the pore spaces. Automatically the whatever you decided objectives will not be reached. And next is relative density. So relative density means it is the indication of degree of packing of the soil grains, hence represents structure of the soil. So loose structure indicates presence of relative large voids, means if you have a relative density, lesser relative density, what happens? You have a loose structures. If you have a loose structures, then you have a pore spaces. If you have pore spaces, grout can be easily moved. But if you in case of higher relative density, what happens? The degree of packing is very high, means gaps are very less, pore spaces are less, then grout will not reach the proper destiny. So that's why you go for, means relative density for looser, means lesser relative density. Next, in properties of the grout, so larger size particles of suspension grout. So if you have a larger sizes of the grouts, then the material can be easily moved and achieve, means strength can be easily achieved. Next, it may be time setting. Time setting means, so usually if you use a cement, it has a setting time. So within a setting time, you have to apply the grout. If you not apply within a setting time, then it becomes hardened. Then after, if you pressure after the crossing the setting time, if you pressure the grout, then grout will not reach because of it will harden. Next called as viscosity. This is very important. If you have a high viscosity, then grout have high viscosity, so definitely grout will not easily move into the pore spaces, means it will not reach the destiny. If you have a grout having low viscosity, then the grouts can be easily move and achieve the degree of packing. It may be, these are the some here another one is spacing of grout holes. The spacing of grout holes, it depends upon the grain size distribution. If you have higher grain sizes, spacing will be more larger, otherwise spacing will be very near because low sizes pore spaces, low pore spaces. Next called as procedure of grouting. So procedure of grouting consists of two steps. That is, first one is pressure grouting and second one is number of stages of grouting. So this is very important. Pressure grouting means it is totally depends on your pressure of the grout. So in this case, what happen? If you have a high pressure, what happens? If you have a high pressure of grouting, if the soil is having loose structure, if you have a high grout, then high pressure, what happens? If you pressurize the grout into the loose soil, what happens? So there is a leakage of the grout takes place, or it may be fracturing of the grout takes place. So this will cause disadvantage. So means then what? We go for low pressure. If you go for low pressure, what happens? The grout will not reach the destiny. Grout will not reach the destiny. Then what to do? If you go for high pressure, there is a leakage or fracture takes place. Or if you go for low pressure, then grout will not reach the destiny. Then to prevent this blowing of grout hole, the grouting pressure is limited. So grouting pressure is decided, that is limited, that is 20 kilonewton per meter square. If you apply 20 kilonewton per meter square pressure, then the grout will not leakage takes place or any fracture takes place, and also the grout will reach the proper destiny and achieve the density. So that is the regarding pressure grouting. So means if you go for high pressure grouting, there is a leakage or fracture takes place. If you go for low pressure, the grout will not reach the destiny. So that is why we decided in between, that is equilibrium, that is 20 kilonewton per meter square pressure is applied, so that grouting is effective. Second one is called as number of stages of grouting. So in this number of stages of grouting, there is two steps. One is called as initial step and second step. So in initial step, what happen? So for example, if you apply for loose structure for high grouting, high pressure grouting, what happens? So there is a leakage or damage will take place or fracturing will be takes place. So that is why in the initial stage, first you apply a low pressure grout so that the soil can ready for taking high pressure grouting and it achieves some strength. When you apply low pressure grout, so that the grout will reaches slowly, then the soil achieves some strength and it ready for the higher pressure grouting. Then second stage of grouting you have to apply. In first stage, what you do? If you lose texture you have, in first stage you apply the low pressure grout so that it will take the grout and it achieves some strength. Once it achieves some strength, then it is ready for taking higher pressure grout. So then second stage of grouting is applied. If second stage of grouting is applied, automatically the soil will be having a resistance it takes, and whatever destiny or whatever objectives we have, it will be reached. So next will be discussed in next class.